Hello, everybody. Thank you for being here. My name is Margaret Gitau. I am Professor of Agricultural and Biological Engineering at Purdue University. Today, I will talk about climate and water data policy landscape and its impacts with an example from work done in the East African countries, Kenya, Tanzania, and Uganda. I would like to acknowledge my collaborators, Nicholas Chigundu from Makerere University in Uganda, James Kiseka from Aid Environment in Uganda, Victor Congo from Global Water Partnerships Tanzania, Bansi Mati from Resource Plan Limited, and Jomo Kenyatta University of Agriculture and Technology in Kenya, and Subira Munishi from the University of Dar es Salaam. When we look at water in East Africa, two key issues arise regardless of what the water is being used for. Water availability varies substantially with time, with region, and with climate. Water deficits are common and interbasin transfers do occur. The integrity of water resources, and we're talking about both quantity and quality of water, are affected by land use, land management, and climate changes. With climate and climate change, we're looking at temperature rise coupled with higher daytime temperatures. Rainfall is becoming more erratic and the extremes more pronounced. Dry periods are far more frequent, and increases are anticipated in evapotranspiration and crop heat stress. Agriculture is by far the biggest user of water, accounting for about 70% of water use globally. Therefore, as we look forward towards modernizing African agriculture and African agri-food systems in general, we need to keep in mind the increased pressures this will exert on our water resource systems. And we need to pay attention to these two aspects, the water and the climate, and their interactions. To do this, we need to know what we are working with. We need the data to help understand what has happened in the past, where are we currently, and what we need to be doing to secure the future. We need to move towards data-driven decision-making and management. So we were looking at climate, water quantity, and water quality data. When we try to move towards data-driven decision-making and management, we ran into a number of issues. Data were incomplete, insufficient, or not there at all. Even when they were available, they were not necessarily accessible. Sometimes the data were accessible, but we found that they were held by different entities, extents, forms, and formats varied. Sometimes metadata were lacking, and so on, all of which made their effective use a challenge. When we looked at the overall situation, we saw that climate and water information was limited, whether it was due to availability, accessibility, or both, and that tools to enable effective data use were anyway lacking. So we started to question whether this wasn't a reflection of the policy framework surrounding data and data management, and therefore, whether these frameworks, or lack of them, was possibly at the root of all the challenges, in essence, hindering effective use of data for decision-making and management. To resolve the issue, we looked at different policy documents, government websites, and other official documents that addressed water and climate data. In addition to documents from Kenya, Tanzania, and Uganda, we looked at documents from surrounding East African countries and other countries in Africa as available, and countries outside Africa in which data were readily available and routinely used for water resources decision-making and management, for a total of 10 countries. We developed a survey similar to what we would do if interviewing a person and used it to gather information from the documents, then analyze the information gathered. Here at the bottom of the slide, you can see some examples of the questions that were posed in the survey. The key things we were looking at: meteorological, water quality, and water quantity data, that's a level 1. Different elements, including format, instrumentation, destination, and so on, that's level 2. And lastly, functionality and accessibility, our level 3. These charts show the scores for the different elements presented as a comparison between where data streams were functional and where they were not. Highlighted at the bottom are the elements that were found key to successful data streams, meaning that the data were available and accessible. Destination, meaning that there was a database or storage system specified as a home to the collected data. Service provision, that there was a commitment to making data accessible to the public. Responsibility, an organization or agency was specified as being in charge of collecting that data type. Format indicates directly or indirectly the format of variables that will be collected and is correlated with data stream success. The more of the elements there were, the more likely it was that the data stream was successful. We noted that, in general, the process surrounding water quantity and quality data were not as well documented as for climate data. Water data are also much harder to get than climate data. For both climate and water data, we recommend building on the elements format, that is, defining variables and standardizing units. Destination, that is, establishing dedicated databases or repositories with cross-database accessibility. Responsibility, that is, specifying who is in charge of what. And service provision, making a formal commitment to making climate and water data freely accessible, at least to researchers and development practitioners. Here I have information on climate and water data products we have developed, featuring both historical and future datasets for 3 pilot watersheds and select 12 stations in the 3 countries, and model parameter sets to facilitate hydrologic and water quality modeling in the region. We have 2 series of products. Series 1 has the datasets, and Series 2 are translation products that I will highlight in the next slide. To the extent that we could, we have provided daily data. Historical watershed data are provided as shareable based on permissions we were able to obtain. The sum of these are aggregated. Our products are developed based on FAIR guiding principles, that the data are findable, accessible, interoperable, and reusable. The data are accessible through the Purdue University Research Repository at the DOI provided at the bottom. The data can be used for hydrologic and water quality modeling or other water resources applications and are formatted for easy use with such applications. As of this October, we have close to 4,000 views and over 700 downloads. The whole idea behind research translation is to provide research results in a manner or using language that can be easily understood by the intended end user, in this case, water resources managers and policymakers. We have a series of products in this regard. This is our Series 2, including a quick reference guide to our data and modeling products, a training manual, scenario evaluations with interpretations, a success story, and 3 policy briefs, 1 for each country. These are accessible through the USAID document repository, the DEC. Sometimes a better way to look at impact is by looking at what we lose if we don't have a product or a resource, as opposed to what we gain if we have it. In this case, if water resources managers do not have the data that they need, it means they are working with limited water resources information, which in turn limits the decisions they can make as well as their ability to manage decisions effectively. That, coupled with the challenges of climate and land use, land management changes, can lead into a cycle that is difficult to break out of, ultimately compromising water security. In general, it's like working with an incomplete picture or trying to solve a puzzle for which pieces are missing. Undoubtedly, you miss valuable insights, might not notice key patterns, are unable to change with changing conditions, and are unable to plan ahead, and so on. If the wrong decisions are made, it can be costly. The whole process of trying to work around missing data, imputing, making assumptions, and so on is in itself very costly. What about when the data are there, but they are not accessible? Oftentimes, the data custodians will argue that it costs money to collect and maintain the data, and thus are not willing to share it freely or will charge a substantial amount for it. One person at a workshop we held last year made the point that it is like building a highway than preventing motorists from driving on it because it costs money to build, or charging amounts that anyway discourage its use. We recognize that there are other reasons behind this unwillingness to share data, like transboundary concerns, especially as related to water. However, there are data protection protocols that can be implemented to get around these concerns without stifling data use. As we move towards modernizing African agri-food systems, we need to be thinking about this. Ultimately, data needs to be available and accessible for use for the common good, and this needs policy-level interventions. Thank you. I'll take questions.